All right, ladies and gentlemen, in this video, our goal is to first and foremost identify the reflexive, symmetric, and transitive properties of equality. We are also going to look at ones of congruence a little later on, but we're going to be looking at the ones of equality, focusing on that equal sign. So what are the reflexive property, symmetric, and transitive property? Well, first and foremost, I want you just to look at what you see in each of these columns for the reflexive property. Real numbers, A equals A, segments, AB equals AB, measures, angle A is equal to angle A. What do you notice? Hopefully you notice that it's the exact same thing on the left as it is on the right-hand side. What do you think of when you think of to reflect? Normally, the answer that I get is something about a mirror, right? It's your mirror image. When you look in the mirror, it's the exact same image as it is when people look at you in real life. And that's what the reflexive property identifies for us. It is the exact same image on the left and the right side of an equation. This reflexive property is going to be super important when we get to things like triangle congruence, because think about how a triangle would be able to be kind of set up. If you say, for instance, that we have, if I can get my pen to work here, if we have a triangle, I'm just going to make a triangle here, and let's say I split it perfectly in half. This is going to be very valuable for us because if you say we have a triangle, we'll call it ABC, and there's a point D down here, what's very, very important to know is that when we're comparing the two triangles, ABD and triangle CBD, notice they share side BD. This is going to be super valuable for us because we're always going to be able to take into account that the segment BD is congruent to the segment BD because it's the exact same thing, and therefore it is equal to one another in length. So that's where a lot of times you get to utilize the reflexive property. We also talk about the symmetric property. The symmetric property is just thinking about symmetry. If you think about what it looks like on a graph, let's use a basic parabola because usually we're all pretty familiar with a parabola. If you see the parabola here, guys, this parabola that I just drew, all right, when y equals x squared, that is perfectly symmetric about the y-axis because what the y value is on the right side of the x-axis is the exact same y value on the other side of the y-axis. Hence, it's symmetrical, or it's the same shape on both sides of an axis of symmetry. Well, in this case, what the symmetric property tells us is that if A equals B, then we can just turn the equation around and say that B equals A. And last but not least, the transitive property. The transitive property will probably be our most frequently used property, and that says if A equals B and B equals C, then of course A must equal C as well. If you remember correctly, I mentioned this when talking about the law of syllogism. Remember, the law of syllogism said if P implies Q and Q implies R, then P must also imply R. And this is kind of that same concept here. If A equals B and B equals C, then A equals C. You will see me reference this statement right here so many times as an example as we continue to go through. So let's take a look at identifying first and foremost a couple of properties used in different statements. It says if the measure of angle 6 equals the measure of angle 7, then I can also make the statement the measure of angle 7 equals the measure of angle 6. Which property does this represent? Well, only thing that changed here was the order. I said 6 equals 7, but now I'm saying 7 equals 6. It's both a true statement, and that is how we use our symmetric property. All right, what about 34 equaling 34? Well, think about it, the mirror image. 34 is the exact same thing on the left and the right side, so that means it is a reflection or the reflexive property is being used. And then last but not least, says the measure of angle 1 equals the measure of angle 2. Also, the measure of angle 2 equals the measure of angle 5. So you think about the conclusion. If 1 equals 2 and 2 equals 5, 2 didn't change in this scenario. So we can make the conclusion that 1 also equals 5 and that is our transitive property. A equals B and B equals C, then A equals C as well. All right, let's dive in a little bit more into some application. Let's think about a scenario here. Now, this is going to act as our very first quote-unquote proof of the school year. Hang on to your seats. It gets exciting. And I'm going to mention a couple terms that you're going to see in 2.5 and in 2.6. It says you reflect the beam of a spotlight off a mirror lying flat on a stage, as shown. It wants us to determine if the measure of angle DB A equals the measure of angle EBC. Okay, so this guy in here is equal to this guy in here. So every time that you kind of start off with proof, you want to identify what do we know. And I'm going to split this up into two columns. This is called a two-column proof. On the left-hand side, you have your statements. And on the right-hand side, you have your reasons. And so you want to start off with what do you know about the problem? What is given to us in the problem? Well, as you can see with these two congruency marks, that the measure of angle 1 is congruent to the measure of angle 3, okay? And so if you can see right here, we know that the measure of angle 1 is equal to the measure of angle 3. That is given to us. And when we get into our actual proofs, we probably should have actually said angle 1 is congruent to angle 3 first, but we haven't gotten quite there yet. So we're kind of skipping a little bit ahead, but I don't want to overskip, I guess, the process. So the measure of angle 1 equals the measure of angle 3. Think about what you're trying to do. You're trying to show that 1 plus 2 equals 3 plus 2. So incorporate that addition, right? That's what you want to show in the end. So I want to show that 1 plus 2 equals 3 plus 2. So let's put it into practice. What do I know? Well, I know that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle DBA. All right? Right? DBA is 3 plus 2 added together. So then you want to kind of ask yourself, what allows me to make that claim? Well, I know that these two smaller angles equal the bigger one because of the angle addition postulate. Okay, well, now let's talk. What do I know? I now have already stated that 1 and 3 are equal to each other. So do you agree that if they are equal to each other, I can change them out with no problem? Hopefully you agree. So I can make the claim that the measure of angle 2 plus the measure of angle 1 also equals the measure of angle DBA. And why did I do that? Because if they are equal to each other, I can substitute each of them right in play. So that is called the substitution property of equality. Okay, let's keep going. I want to introduce 1 plus 2 because the goal is to show that DBA and EBC are equal to one another. So let's actually introduce EBC into the mix by saying the measure of angle 1 plus the measure of angle 2 actually equals the measure of angle ABC. What did we do before? What allowed me to make that claim? Hopefully you see that's the exact same thing that we did before with the angle addition postulate. All right, now we're flying. Look what we do these last two steps. Please, please, please take a look here. What do you notice in these last two steps? We have made the claim that the measure of angle 1 plus 2 equals DBA, and we've also made the claim that EBC equals the measure of angle 1 and the measure of angle 2. The only way this works is if what? Finish that statement off. Hopefully you see that the only way this works is if the measure of angle DBA is the same thing as the measure of angle EBC. So Think about it. Think of our last set of reasons, right? What have we talked about? Reflexive, symmetric, and transitive properties. If A, right, equals B, and B equals C, then A must equal C as well. I guess I should probably do it the other way. If A equals C, right, or B, and B equals C, then A equals C as well. That is a prime example of our transitive property of equality.